Hello, I welcome you all for this video lecture. In this video, we will discuss Kmedoid clustering algorithm for making clusters. This algorithm comes under partitioning clustering approach. The other name for this algorithm is PAM algorithm, that is partitioning around Medoid's algorithm, and it was proposed in the year 1987. In this algorithm, a central data object called Medoid is used to form the cluster instead of mean value as used in the k-means algorithm. Here we need k number of medoids to form k clusters. The objective of this algorithm is to improve the quality of the clusters. This is an algorithm. Here we have two inputs, k and d. K is the number of clusters which is defined by the user. D is a data set containing n objects. Output of this algorithm is a set of k clusters. Algorithm steps are follows. First, randomly choose k data objects from the dataset as the initial representative objects. These objects are called medoids. Then compute the distance between each medoid object with every other non-medoid objects using Manhattan distance function. After computing the distance, assign the non-medoid objects to their nearest medoid cluster. Now k clusters are formed. Then compute the total cost for forming k clusters. Here the word cost and distance are used interchangeably. Next, choose any other non-medoid object, that is O random, from any of the cluster and consider that as the new medoid object and compute the distance between new medoid object and every other objects in all the clusters. Then assign non-medoid objects into appropriate clusters. Again compute the total cost for forming k clusters. Now we calculate S value. S is nothing but current cost minus previous cost. Then check if S is less than 0. Then swap OJ with O random, that is old medoid with newly selected medoid. Repeat the steps from 3 to 6 for every possible combinations of medoid. Next, I'll explain the algorithm using simple example. Here we have two attributes x and y and 8 tuples a1 to a8. Let's make three clusters from these 8 data objects. For that, first we have to choose three medoids. Here I have chosen A1, A4 and A7 or initial cluster medoids. Other data objects are considered as non-medoid objects. Now we will find the distance from each non-medoid objects to medoid objects. Here, Manhattan distance is used to compute the distance. Formula for that is distance of x comma y is equal to x1 minus x2 plus y1 minus y2. Here only the absolute values are considered. Why I have mentioned only two terms in the formula is we will find the distance for 2 points uh, x1 comma y1 and x2 comma y2 at a time, since we have only two attributes x and y. Now we will see the iteration 1 of the algorithm. Here we calculate the distance from n minus k non-medoid objects to k medoid objects. Already we have chosen A1, A4 and A7 or medoids for first, second and third cluster respectively. The distance is calculated using Manhattan distance. After calculating the distance, place the data objects to a cluster with the nearest medoid. For example, consider the data object A2, that is 2 comma 5. The distance from 2 comma 5 to the medoid A1 is 5. 2 comma 5 to second medoid is 6. Third medoid is 4. Among these three distances, 4 is minimum. So 2 comma 5 is placed in the cluster, that is 3. Similarly, we have to place the other non-medoid data objects into an appropriate clusters. Now we calculate the cost for forming clusters by adding the distance of data objects present in that cluster. Cost for forming cluster 1 is 0 because it has only medoid object for that cluster. Cost for forming cluster 2 is 19, that is 7 plus 0 plus 5 plus 5 plus 2, that is equal to 19. Cost for forming cluster 3 is 4. Total cost is 23. This is the medoid table used to keep track of medoids chosen in each iteration along with the cost. This diagram shows the clusters formed after iteration 1. Next, we'll go to the second iteration of the algorithm. Here also, we have to choose any non-medoid object from any of the cluster. Here I have chosen A5 as medoid object. In this iteration, A5, A4 and A7 are medoids for first cluster, second cluster and third cluster respectively. Next, compute the distance from all non-medoid objects to medoid objects as done in the previous iteration. After computing the distance, relocate the non-medoid objects into the appropriate cluster based on the minimum distance. For example, consider the data object A3 is 8, 4. Distance from A3 to first medoid is 2. Second medoid A4 is 7. Third medoid A7 is 9. So among these distances, the distance from A3 to first medoid A5 is minimum. So it is moved to cluster 1. Previously it was in cluster 2. Now calculate the cost for forming the clusters. The total cost here is 15. The data objects present in the clusters are given here. After iteration 1 and iteration 2, we can find the value of S, that is the difference between the costs. Now S is equal to 15 minus 23, that is equal to minus 8, which is less than 0. So A1 and A5 are swapped. Now A5 will become the new medoid for the cluster 1. After iteration 2, these three clusters are formed. Cluster 1 contains 3 data objects, cluster 2 contains 3 data objects, and cluster 3 contains 2 data objects. Here A5 is the new medoid for cluster 1. Then go to the next iteration, is iteration 3. Continue the process for all possible medoids. Finally, A5, A4 and A7 are medoids with minimum cost and the clusters obtained are shown here. This diagram shows the output clusters. After iteration 2, there will be no change in the clusters because S is not less than 0. Next, we'll see pros and cons of Kmedoid algorithm. Kmedoid is less influenced by outliers. It is only suitable for small data objects. The time complexity of this algorithm is order of k into n minus k the whole squared for each iteration, where n is the number of data objects and k is the number of clusters. So, sampling based methods, Clara and Clarence, were proposed for clustering large data sets. Thank you.